Now let's talk about how to solve related rates problems. The first thing you need to be able to do is read word problems and basically a verbal statement and pull out the mathematical model. So if I were to tell you that the velocity of a car after traveling for 1 hour is 50 miles per hour, you would need to write that x is the distance traveled and dx dt is 50 when t is 1. Or if I were to tell you that water is being pumped into a swimming pool at a rate of 10 cubic meters per hour, well, you need to recognize this as a volume, so V is the volume of water in the pool, and dV dt is 10 meters cubed per hour. Similarly, if I told you a gear is revolving at a rate of 25 revolutions per minute, and 1 revolution is 2 pi radian, then theta is the angle of revolution, and d theta dt is 25 times 2 pi radians per minute. So you need to be able to be very clear with these mathematical models. There are some steps and guidelines for solving related rates problems. Now, in related rate problems, you have two variables or more variables that are related, that are changing. So we're going to be looking for dx dt, dy dt, dv dt, dr dt, that sort of thing. Everything is changing with respect to time. That's why it is a rate problem. So the first thing you're going to do is identify everything, what you're looking for, what you have. You're going to draw a sketch, and you're going to label. Then you're going to write an equation involving the variables whose rates are changing. And then you're going to do implicit differentiation of the equation with on both sides with respect to time. And after that, you're going to plug back in your known variables and solve. Now let's try one. Suppose x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. Find dy dt. So this is what I'm looking for. So dy dt is equal to what when x equals 1, given that x equals 1, given that dx dt is 2 when x equals 1. So this is what we're given, and this is our unknown. Not really a picture to draw. So the first thing we're going to do is take the derivative with respect to t of the entire equation. So the derivative with respect to t of y is dy dt. The derivative with respect to t of x squared is 2x dx dt. We have to use the generalized power rule, plus 0. Now, we want to find dy dt when x is 1. So dy dt is equal to 2x dx dt. So at x equals 1, let's see if I can plug in what I have. Dy dt is 2 times 1 times dx dt, which is 2. Now, you'll notice I didn't have to solve for y. Over here, I could have solved what y was. At x equals 1, y is 1 squared plus 3, or 4. In this particular problem, I didn't need it, but that's another hint. You may need to do that on a different problem.